In the 163rd video on Financial Math for Actuarial Exam 2, we're going to look at 2017 SOA Sample Exam problem number 190. We've been looking at these sample exam problems recently because they really provide you with what you need, more so than the exercises in Broverman's book. We'll be finding the new interest rate when the first-order Macaulay approximation is used to find the new price of a bond portfolio based on some information. That information is the original price, the original interest rate, and the original Macaulay duration. And it is a portfolio that we're dealing with here. We've got a couple bonds. So SOA Life Insurance Company, I guess that would be the Society of Actuaries Life Insurance Company, has a portfolio of two bonds. Bond 1 has a Macaulay duration of 7.28 and a price of $35,000. And Bond 2 has a Macaulay duration of 12.74 and a price of $65,000. The price and Macaulay duration for both bonds were calculated using an annual effective interest rate of 4.32%. Bailey estimates the value of this portfolio, it is a portfolio, two bonds, you're combining together in your investments, at an interest rate of I, using the first order Macaulay approximation to be 105,000, determine I. Okay. Before we solve the problem, we should state a principle here. And that is, if you have a portfolio and you know the prices of the bond, say a portfolio of bonds, and you know the price of the bonds in the portfolio and their Macaulay durations, you can find the Macaulay duration of the portfolio itself, the combination of the two investments in this case, by taking a linear combination of the Macaulay durations of each thing individually, where the coefficients, the weight in the linear combination, the weights are determined by the relative sizes of those prices compared to the overall value. In particular, you can say the Macaulay duration, DMAC, total, I'm going to write it as it's shown in Broverman's book, at interest rate I, is a sum. Say you've got a portfolio of M investments, it could be M bonds. Sum K goes from 1 to M, of UK times the Macaulay duration of that kth investment at interest rate I, where UK is a weight, and the sum of the UKs is 1. This weight, UK, is determined by doing the ratio XK divided by X, where XK is the present value of, I'm going to go ahead and just call it a bond here, bond K, or in general investment K, and X is the present value of the portfolio. Pretending it's a portfolio of bonds, it would be M bonds. We're going to apply this in this situation where M is 2. So we can first figure out the Macaulay duration then of this portfolio by this formula. DMAC total at the given interest rate of 0.0432, 4.32%, to be, okay, a linear combination of these two Macaulay durations where we take the coefficients, the weights, to be, for the first one, 35,000 divided by the sum of these two, which is 100,000. And the second weight, U2, would be 65,000 divided by 100,000. Let me go ahead and just use units of thousands. So that's going to be 35 divided by 100 times 7.28 plus 65 divided by 100 times 12.74. Since the one with the longer duration has the higher price, that's going to have more weight in the total calculation for the total duration. The value of the total duration here, Macaulay duration, is going to be closer to 12.74 than it will be to 7.28. 35 divided by 100 is 0.35 times 7.28 is 2.548. Go ahead and store that in register 1. And then 65 over 100 is 0.65 times 12.74 is 8.281. Add those two, and you get a duration for the portfolio that is 10.829. Okay, so that will be the Macaulay duration that we use then to help us finish this problem. So now we're ready to finish the problem. We need to use the first order Macaulay approximation that was introduced in the last video, video 162. And that formula is that the price at interest rate I, which we could represent as some given interest rate I0 plus some change in the interest rate, delta I, is approximately the price at the original interest rate I0 times 1 plus I0 over 1 plus I0 plus delta I, all raised to a power that is the Macaulay duration at interest rate I0. This could also be written as P of I0 times 1 plus I0 over 1 plus I to that Macaulay duration power, because I'm taking I to be I0 plus delta I. Our goal here is to find I. All right. We are given what I0, that's the 0.0432, that's what I0 is. We're given the Macaulay duration now of the portfolio. We figured it out to be 10.829. We are told that when we use the first order approximation, we get 105,000. That will be the value of P of I. And we also knew the original price to be 100,000. So the equation would then be 105,000 equals 100,000. Now do this fraction here. 1 plus I0 is 1.0432. In the bottom, I've got 1 plus I. I is the thing I need to solve for. Now put that power to be 10.829. Divide both sides by 100. We get 1.05 equals this. I would then raise both sides to the power that is 1 over this number. I'll go ahead and write a 1 over 10.829 here. That will equal 1.0432 over 1 plus I. And this is all going to mean, after I multiply both sides by 1 plus I and divide both sides by this, and then subtract 1, that I will be 1.0432 divided by 1.05 to the 1 over 10.829 power minus 1, and that will be the answer. So I just have to do that calculation now. Let's go ahead and take the reciprocal of 10.829, reciprocal button. The reciprocal is about 0.0923. I'll store that in register 0. I need to take 1.05 raised to that power, 1.05 to this power. That becomes the denominator of this fraction. I think I didn't do it there. Let me try that again. 1.05 raised to that power. There we go. That's the denominator of the fraction. I need to divide by that so I can take its reciprocal and multiply times 1.0432 and then subtract 1. And I is about 0.0385, 3.85%. And that is one of the options for the answers in the sample exam. It's option C, and it is the correct answer to this problem here. Thanks for watching.